In the last video, we looked at the derivation of the formula for the sum to n terms of an arithmetic progression. And this is the formula that we got. The sum to n terms is equal to the number of terms divided by 2 multiplied by the first term plus the last term. Now, with a question like this, for example, if I said I wanted to find the sum of the first 100 counting numbers, so 1 plus 2 plus 3 plus all the way up to 100, that's a relatively easy process to go through with this formula because it's pretty easy to tell that the 100th counting number is 100, so I can find my L really easily. I know that the first term is 1, which is A, and I know that the number of terms is equal to 100. This would be a pretty straightforward thing to stick into this formula. Unfortunately, however, we sometimes actually don't know what this last term is going to be, which means that a lot of the time when we're working with a series, we don't have the number to substitute into this L position in the formula. Take, for example, the sequence that's defined by 1, 7, 13, 19, and so on. The common difference here is pretty clearly 6. And the first term is clearly 1, but if I said something like we actually don't know what the last term is. And so we wouldn't be able to straight away use this formula. So what we want to do is we want to rearrange this formula so that instead of having an L here, we can deal with the situations where we have an A and a D. So we want to replace this L with something in terms of A and D so that we can calculate in this kind of a situation. So to do that, what I'm going to do is I'm going to do a little bit of a substitution and a tiny bit of algebra. We're going to start off with this formula, and we're going to think about how we might be able to replace this L. Now remember that L stood for the last term in the series, and if we're doing the sum to n terms, well, that's the same as Tn. And we actually already have a formula for Tn. Remember from our work before, the nth term of an arithmetic sequence is equal to A plus n minus 1 lots of D. So what we can actually do is take this part here, this expression, which contains an A and a D and an N, and actually use that to replace the L in my formula. So I'm going to rewrite the formula. The only difference is I'm going to use this expression instead of L. So it's plus A plus n minus 1 lots of D. So I've just replaced that L with this blob here. So the L has turned into this. That A is still there. That n on 2 is still there. And now I'm just going to rearrange this. I'm going to simplify the algebra. A plus A is 2A. And I still have n minus 1 lots of D. And I'm going to take this as an alternative formula to the one that I had above. So here we have it. This is the formula for situations where I don't know what L is going to be. I'll take both of these, I'll put them down the bottom, and then we've got a nice summary of them. So I have this form of the equation for situations where I know the first term and the last term of the number of terms. I have this form of the equation when I don't know that last term, but I do know the common difference. Okay, so we'll write that over to the side here. Use this one when I know A, when I know L, and when I know N. Use this one when I know A, D, and N. So depending on how much information I know about my series and what I know about it, we choose a different form of this equation.